Hello everybody. Today I would like to show you how to download, compile and use the user subroutines using Windows and its tools. So thank you very much for attending and let's get started. First of all, we need to clone and fetch this repository, which we'll find by going to OpenRadioss.org website and then going for downloads to GitHub. And here within this download section, we will go to one level above to OpenRadioss, where we see OpenRadioss itself showed in the previous video, as well as Model Exchange and Tools. And Tools, this is where we want to go. Here we'll find this userlib SDK, the software development kit, as well as some examples. So let's go for it. First, I would like to give a star watching it and forking it to my own user and create the fork. So now I can see, if I go here on my repositories, I see, in addition to OpenRadioss, I see also now the tool repository, and I'm getting here. So now I'm in my own tool repository. If you enter it on a different day, then you should always double check if you have the recent code, and if not, then go just for it. But here it is, because I did it right now, I have the most recent code. So, and now let's get and clone it down to my local machine here. Now, after forking the tools, which contains the software development kit, the userlib SDK, we are going now to fetch this, and for this purpose I'm going to start directly my Intel One API command prompt, which already invokes the compiler, the necessary compiler environment, using always Intel 64 for a 64 machine. So this is what I would like to recommend. How to install these tools I explained also in the previous video, so please review it, as well as on how to use GitHub. Okay, so here now we go to our work folder. We see we have still the OpenRadioss source code, which is already compiled and tested. Now we're gonna clone our own repository, which we have created. So to do this, we go git clone git github.com download open. No. And we are cloning now the tools repository to our local machine. This is done now. Here we have this additional tools directory where we're gonna now to step in, see what's inside. Here we have the README, we have also the userlib SDK, so which we wanna go to enter. Here we are, and here it is displayed also more in detail how to use it. So first of all, I want to compile the necessary libraries which we need for compiling our own user subroutines for OpenRadioss. So how to do this? I'm going to use the prepared Windows batch file. If you don't know how to use it, just launch it without any arguments. So you see now here in the documentation or short description how to use it. So we are going here, arch equals to win64, and default settings for compiler is already the one API compiler from Intel, so this is by default. I can add it as if needed, but usually not necessary, but I will do it anyway here to show. And now the necessary source code files are being compiled into the needed modules which we need. This step has to be done only once. So now the necessary software SDK, software development kit is already done. So we can proceed now to the examples. So there's already one example provided to see if it works, which contains a beautiful one solid element, just a model with a user defined material. So here we are. So for user subroutines, we need to compile two different pieces. One is for the starter, which contains the information on the data which should be read in from the models. So this is done here in the lecture end user 01. You can open it and see what's inside. Here we see, so it reads in from the input tag these three values: Young's modulus, Poisson ratio. The density is read from a routine above. Some checks and the parameters which are pre-computed are provided as user parameter for the engine for later on applications. Here we are just change the date where it is used, which is today, just to see it on the output file when I will use it, if the correct dynamic linked library is used. So I'm going to save it. And for compilation, I need some additional environment variables, which are described deeper in the tools section in how to use the userlib SDK. So using this under Windows, we need to set two environment variables. First one pointing to the userlib SDK folder, which is down below here. And there's a subfolder which is also called userlib SDK. That's okay. Second environment variable for being able to compile my own material models as user subroutines, to set the archive, which is bin64 underscore one API. And now I'm prepared. So I can now also fetch the batch script, which will help me to do it in an easier way, which is also prepared in the user lib SDK folder in 64.1 API. So this is the build script, which I just fetch and drop here into this folder. And I can immediately use it. How to use it, it's also described a little bit inside here. So just starting without any arguments, it shows how to use it. So this is the way we have to use this script. So let's do it. Starter is the lecture and engine, which points to the L-user material model, and starting now compiling my first own user-defined material model for Radioss. Here we are. This is what we are looking for, this dynamic linked library for Windows. If you do it with Linux, you will get the SO, which is the shared object. Similar approach like we did it now. So, okay, I create now a new path, new subfolder for my calculation and copy my model files into this cluck file. Copy also this.dll into this and entering it. Where is my here? Now I have everything I need. Now I need to also to preset the, so it is already run-able, so I can have a look in my model file. So this is my user-defined material model, which contains these two informations which are needed for this simple hook. This is the classic hook material model. So I need to preset some environment variables, which are more deeper explained here in the OpenRadioss section. How to run OpenRadioss for Windows. So I have to set first, this is the only environment variable I have to tune to adjust a little bit. So this is my OpenRadioss path to my OpenRadioss directory. So the rest can be just simply copy and paste. KMP stack size is needed for larger models. Path to the necessary additionally provided libraries which are needed for reading in the model. So, and I will add also one which is pointing to my executable folder, which contains the starter and engine executable. So that's all. Let's go for it. Using the starter. minus I. Here we are. Starter run correctly, and now the engine. The 0001.rut minus number of threads set to 4, even if it is just one element model. And you see here it's running now till the end. This is just one element number 7, and I have added some additional printouts for the individual stress value of the stress tensor, just to see if it is working. So I'm checking the folder, everything is now done. Checking the out file. First, to check if this user subroutine was really used, is to go into this output file from the starter, and you see an external library for users code interface was used, which is this name here, which is good. Continuing here, this was the text which I have adjusted previously, the actual date and the two values which I will read in from the material, and so it's performing quite well. And this is all. I hope you liked this video. If yes, give me a thumbs up. Otherwise, have a nice day and look out for more videos which will come. Thank you very much, and bye bye.